When working with a set of orthogonal unit vectors, it's useful to have a quick way to remember what the cross product is between different unit vectors. So here we have a 3D drawing of a basis consisting of 3 orthogonal unit vectors. And of course, by definition, we have that the angle between any of the vectors is exactly 90 degrees. So we already saw that from the definition of the cross product of any vector with itself is going to be 0. So each of these cross products is 0. But what about all the other terms that we could have? There are a few clever tricks for remembering these values. One method is to appeal to the alphabet. So I've written down x, y, and z in order and appended an extra x. And we're going to define this direction as positive and this direction as negative. So to use this method to fill in a few of these values, we could ask, for example, ny crossed with nx. We look down here, we go y cross x is moving backwards. And the result, of course, has to be z, because it's perpendicular to both x and y. So ny cross nx is going to be equal to minus nz. And as another example, let's do ny cross nz. So we look here and say ny cross nz, that's moving in the positive direction, and the result is nx. Another method some people like is to draw a circle with a peace sign in it like this, and then place x, y, and z in a counterclockwise rotation. And then we define positive as a counterclockwise rotation and a clockwise rotation as negative. If you have trouble remembering this, you can think with your right hand, your fingers curl like this, and that would be positive. So to use this to fill in a few values, let's think nz cross nx. So we go nz crossed with nx. We're moving in the positive direction, and we get ny. And let's do another one, nz cross ny. Here we have z and then y, which is moving in the negative direction, so the result is negative nx. And finally, some people just like to use the right-hand rule on the unit vectors themselves. So for example, if we point our fingers in the direction of nx and then curl them toward ny, our thumb points in the direction of nz. So nx crossed with ny is positive nz. And to do the last one, nx cross nz here, we point our fingers in the direction of nx and curl them toward nz, and we'll realize that our thumb is pointing down, which is negative ny. So there you have 3 useful memory devices for computing the cross product between unit vectors in an orthogonal basis.